Welcome to Rubber Duck Engineering. Tonight, we're going to explore wave function collapse, which is an algorithm for terrain generation. I'm sure I'm getting
not quantum mechanics, terrain generation.
Yeah, it's like a game. It's like a thing that's like taking popularity in the game space in a while. It's for like procedural generation of terrains. It works in both 2D and 3D. And given our game kick of late,
yeah, we did a terrain generation in a previous episode using Perlin noise, which allowed us to sort of generate like it sort of felt like a cave. Like there were like open areas and closed areas of the cave. But this wave function collapse algorithm seems a lot more general. It seems like we can generate all kinds of different environments with interesting things at each location.
Yep, it does. It's as far as I can tell, and there's a bunch of YouTubes on. You can, if ours doesn't make it clear, you have a tile set, which have adjacencies, allowed neighbors between the tiles, and it basically slaps down a random one and collapses then the space of possible tiles around that to a smaller set, and then slaps down one adjacent and builds from there. And I think you can slap down multiple tiles and like fill in, and then when it hits collisions, it gives up and tries again. Like impossible scenarios. But according to the author, those are actually quite rare in most tile sets. So, and you'll see this in things like there's Townscaper was a game that people may have seen on Steam and iPad and stuff that uses this idea. So, any thoughts before we get into it?
Should we show the README? There's a repository that we're working from as an example that documents the algorithm and also provides some tile sets that we can explore.
Yeah, that would probably help. So here we go. This is a GitHub I found. I've seen it also as a waveform collapse. And this initial presentation of it is taking a single bitmap and slicing that up as the tiles. But also, I think more generally, if you go down here, it's given a set of tiles, like these two tiles. Generate these. And there's adjacencies. And this README goes through the algorithm, and here's a GIF of it going. You can see it sort of grows to fill in.
I think it's sort of like it goes for like the tightest, most constrained part first and tries to work that out, and then sort of works towards lesser constrained parts of the image later, which makes sense. Otherwise, let's try to avoid getting stuck.
And it seems to work super well. And again, it works for 2D and 3D. I'm sure there's much more sophisticated examples than these. And this particular thing talks about how it's been ported to everything except Dart, which I think we're going to write
until tonight.
Until tonight. And now they have the algorithm written out here. I guess I can show you. I mean, we'll get to this as well, but like here in this example, and there's lots of other ways to specify, but here's the sort of tile set. So I think we were going to talk about doing possibly the circuit one. So here's like a bridge. Here's a component. All these just tiny little tiles. There's a transition. And then accompanying this is an XML file where they list out the tiles. And then they give the neighbor connections. They're saying a bridge tile can be next to a bridge tile. A bridge one can be next to a bridge one, etc.
These like allowed adjacencies between the tiles.
Correct. And they just do left-right pairings, and you obviously can rotate that. Obviously, you could specify this another way. This is just how they set up their test cases.
Thanks for joining us.
Okay. Shall we to the Go machine?
To the code machine.
So I'm starting with basically a blank Flutter app. I took one of our other examples that just had a stateless widget with a custom painter, and I emptied it out. It's got an empty paint function, and it puts the custom painter inside a stateless widget, inside a stack. The stateless widget is kind of.
So we should talk about like what is the like MVP here? Like what is the dumbest version of this we can think of? The dumbest version I can think of is it just draws the tiles in random places and does not know anything about the adjacencies.
Okay.
and then we can see that it's all messed up, and then we can apply the algorithm to make it not messed up.
Okay, so things that we might need for that, because I always jump straight to pseudocode to like help me think. Whoa, what did it do? What was that CodePilot again? Load. CodePilot is super great alone. It does not seem to get along nicely with the code sharing thing. What was it? Init state. There we go. This thing. Init state. We might
Like load the tile set. You mean like load that XML file?
Mm-hmm. We don't even need the XML file to do what you're talking about, but like load.
Oh, I thought the XML file would help us find the actual tiles instead of like scanning a directory.
Ah, yeah. Load. Okay. Load XML file.
We're going to need some object that represents like which tile goes in which location.
Mm-hmm. And then in this, we need to draw the grid of tiles.
All right, so I'm going to make a class for like the tile store.
See, it just painted in. What did it do? Oh, it just gave me a paint. This is sometimes. Okay.
Like a tile map maybe, which is going to have like a list of lists of hints, which is like the map.
Yep, it's like our grid class before.
Yes,
that's true. You can copy over if you want, but
I think this is fine. We can just initialize this with like a width and a height.
This is not. Was this Copilot or something?
Yeah, that's what Copilot put in there.
I love it.
I'm really enjoying like writing code with Copilot because it's like nonsense, but it's like sensible.
Yeah, but it gets you in like general direction, and then you like fix it.
Yeah,
it saves so much typing. I worry it makes me write way too verbose code because I can.
Yeah, because it just fills in verbose code. I think I want to put this in the initializer list instead of in the.
Yeah, but at some level, maybe that's okay because I do think
this isn't right. There's a function called filled.
Oh yeah, it gets the names of things wrong all the time. It clearly has no, and maybe this is just a Dart thing that it just like doesn't know the function names for Dart super well. Okay, so we need to the tile store. We need to like string name. Okay, and then we want tile store this name. We want load catalog. It's like, whoa. Oh, it's not category. Load catalog. Copilot, come on, stick with it. Catalog. Often our parallel coding again.
This is going to be async, like a loading.
It could be, sure. Right. I mean, we're just sort of hacking something together here. The path is going to be. I'm trying to remember Dart paths. I'm writing Python recently. Import. It's like package path.
Mm-hmm.
Yeah.
Okay. We need to add that to our pub spec if we don't have it.
Yeah, it should have a quick fix for that. Does it not? It really should.
That's good.
Feels like a quick fix it could add. I could post on the Twitters or in the bug database. No, I do not want.
I'll
survey season.
I don't know what.
I got it. Flutter pub add path.
That fills in like a sensible version for you.
Yeah. That seems to be the only way to do it. I don't know how to. It also puts it with the hat thing.
Oh, okay.
We're also going to need Dart XML parser. Like I don't need a good one. I just need like a one.
Sounds sensible.
Got a good name. It's squatting on the best name.
They got there first. They're either a good XML parser or they're confusing everyone in the whole world.
Okay.
All right, I'll add that to the top of the thing.
So this should, sure. I'll take your code, Copilot. Path is equal to path.
We don't need the new here, though. We're awesome. We live in the future. I think we're going to need Dart.io.
I actually don't know what the path operations are.
I don't think you. Are you assuming that like the catalog is going to be called like circuit, and you're going to go find it or something?
Yeah, I'm just hacking this in, right? I
can
tell you the path.
I've imported path as path, and I've done like path.join.
Anyways, the path is wave function collapse.
Okay.
File sets catalog.xml. And then the files are at tile sets catalog / name.xml or .png. That's where you want to get the files. And this could have like presumably have like a base, really fancy, but path, assets.
All right, we're going to have to figure out how to parse an XML file. I'll start researching right now.
Yeah. Thank you, Copilot. Copilot is definitely one of those things where like you can tell that it is a part of the future. Like the future has now changed. I just don't know what to.
I haven't found the function in the XML library that actually parses XML.
Okay.
I assume there is one.
XML document parse.
XML document. Okay, that sounds legit.
XML document parse read file read as string sync. This is I'm just reading the README. All right, what is it that I want? I want.
Copilot knew the answer. It turned out. I feel like this stream is just becoming like an advertisement for Copilot, which is not at all intentional.
Yeah. I mean,
yeah, I totally work with interns and managing. I actually started out as an intern at Google. I don't know. I've had great experiences. I don't know, Eric, if you have experience.
Oh yeah, I will say I've had different experience at different companies, but at Google, the hit rate has been amazing. Like just the interns that have come through have been amazingly productive individuals, and I have desperately wanted them to come back as full-time. And sometimes they're lucky enough that they do.
Oftentimes the people who are amazing have many, many options. And so you have to, the experience of the internship is a good way of like learning what the team is like, and like it helps on the sell side too.
Yeah. Current path.
Okay, so we parsed our XML document, and now we got to do the fun of iterating through an XML document to find anything useful.
Did you figure out how to get to the correct relative path?
What do you mean?
Like how do you get p.join just does it?
Mm-hmm.
I see.
I think file open will. I mean, we can try it.
All right, we'll try it. All right, what is it mad about? Okay, it's type string cannot be assigned to type path.
Yeah, that just works in strings. It's paths are not really strings, but everyone pretends. So okay, should I go on my string path rant? Is that an appropriate rant?
Well, we did our Copilot sales pitch. Sure. Insert the string path rant tape.
String path rant. So let's say in Linux, almost all file systems you encounter, paths are just byte sequences that don't include, I think, the null character or the slash character. And which means you can have totally unencodable binary, like you can have like a PNG be a file name, but also like most software in the world assumes you can store paths into string variables, which sort of assume that it's a Unicode path. So if you create a file that has a non-Unicode sequence in it, you're going to break all software in the universe. And so if you're a security researcher, this could be a fun thing to do, is see what happens when you confuse the living daylights out of every piece of software by feeding it a non-Unicode character. Google takes interns from high school. Oh, I haven't tried. I wasn't aware of that. I've never had a high school intern. I've always been involved with the college recruiting folks.
I've never had a high school intern either, but I have had freshman and sophomore interns. So Google has a whole bunch of sort of get into Google programs of various forms. So I wouldn't be shocked. I don't know. You can go to careers.google.com to find out more. But we've had the sophomore or the freshman and sophomore interns, and they're interesting because they come in pairs. You get two at once, which is cool because the intern has a buddy then.
Should we test this out to see whether this is working?
It's totally gonna work. First try.
First try. Okay. So does this XML? Can we query for the tile element? I think that's how we're going to find the tiles.
Right there. Copilot knew what to write.
Oh, great. We want tile though. We want all of them. I assume we can iterate over them, right?
Well, we can also just find first. I bet. I don't know what options we have here. Find elements. Find all elements. What's the find elements versus all?
Let's get attribute name. Let's just print out element get attribute name. Yeah. How does Copilot know everything? Okay, so I think this is I think we should try running this and see if this does something sensible. It's okay. You don't have to fix its consts.
You gotta make the links happy. It's an important part of. All right, I restarted.
Did you ever call the load catalog function?
No.
We need to call it in it. Let's say
totally cheating.
Without tile store.
Except the catalog. This was supposed to be the name. Like this. We want this name. We don't want to pass the. I don't know whether you call this from the constructor or.
Circuits, right?
This get tile index is wrong. This is get tile name.
Load catalog.
Oh, image asset. That's wild. Not a terrible idea, but sure. Okay.
I'm just going to make this synchronous for the sake of simplicity here.
I agree. I don't think it matters. How did Copilot do that? Okay. And I think the get tile should work.
Okay. Do you want to try running it and see if this?
I actually think we can try running it.
Okay, that looks sensible. I think those are the names of the tiles.
Why is it such a funny? Oh, I see. Okay. Yeah.
We should put the. We should remember the catalog somewhere. Like, what are we trying to remember here?
No, like maybe this is just part of the the factory constructor or something.
Okay.
Tile store from path or something like that. Tile store with name. I don't know.
Okay. We just put as part of the constructor. You're saying with name, and we just put just like this. We're overthinking it.
I'd like to overthink it.
Okay. So do you want to keep a list of these or like a set? Set?
Yeah, I think you want to keep.
Names.
Do you want to just load them all here?
Oh, load the images for them? Sure. We could. Well, there's already an image cache. We don't need to do that.
Yeah. So what are we?
We're going to need to remember all the adjacencies too, right?
Yeah, we're going to have to load in all the adjacencies. So we might as well load those in now.
Yeah.
Right. We could make our little.
They're called neighbor.
Oh, you had it right.
I don't really understand this left and right thing, but I guess it'll become clear as we go further along.
What do you say?
I don't fully understand what left and right means. Like, why isn't there top and bottom? Because they're all rotatable.
You just rotate them.
Okay, but they have different symmetries, right? So, I'm looking at the. I don't know if you want to pull up the XML file that we're dealing with if people want to see it.
I see. You're right. You're right. That may actually not work. Let me see. How do I pull up the XML file? Probably through here. It's easy. We can also go look at the code and see.
So you see, if you look at the top, it says symmetries
symmetry?
T and I. It was documented in the README what these different symmetries mean. Let's see. T symmetry is left and right symmetric. If you go to scroll up to tile map generation, go down. Yeah, so it's the same symmetry that these letters have. You see, the X symmetry is symmetric in all four ways. The T symmetry is left-right symmetric. The I symmetry is left-right up-down symmetric. Mm-hmm. The L symmetry is diagonally flippable. And the backslash symmetry is also diagonally flippable.
Still, how do you do left-right? Like with your T symmetry, you still want to have something to know what can go in the bottom.
Yeah, what can go on top and bottom of the T symmetry. It's not clear to me. But I think we're overthinking it. Let's just record this data. Maybe let's not do the neighbor thing right now because we don't need it yet.
Yeah, we just want to spam these tiles out, draw them, see if we know how to draw them.
Okay, so now we know how many tiles we have. I think the set will keep track of its length, and so now we can do a thing. What's that?
Yeah, you want to pass this in, and you want to grab a random tile.
Well, I think we should pass in a tile map that then says which. Do we have a tile map? And then the painter should. Yeah, we have a tile map. So then we can use the painter to look up. All right, so this is not really a set. This is a list because it has indices. Image.
Okay.
By index. Index. And what that'll just do is call
index. This is going to be final random. int.
What if the painter should do this? We should I think the painter should have a tile map and a tile store, right? Tile store.
Okay.
And it should just use the tile map for lookup in the tile store.
What is the tile size?
This is like the tile map get tile index at x and y. We need to figure out what the x and y's are. Whatever that was, that looked good. I feel like we're both typing here.
What'd you say? I let CodePilot spam, and now I'm editing. I'm learning this new way of coding.
Seems sensible. Let's tile size. Okay.
What was that?
Oh, but width. What about height? We're not going to worry about height.
What do you mean?
You just have tile size here, which is only encountering the width.
Oh, that was just CodePilot spam. I don't know what we need to figure out what the
sensible, but it's tile width, and this is going to be tile height, and it's going to be x times height, width, height, and height.
We could also just guarantee the scale, but yeah, we could just always draw a square. But yeah.
Okay, so our tile map needs a width and height according to CodePilot, which is not a problem.
So I'm sorry, what's the difference between the tile map and a tile store? I didn't look. Tile map. Oh, I see. This thing stores which tile per. So you generate the tile map and then you just draw it. All right, fine. All right, so then the only thing we have to do. So, all right, so that makes this painter super dumb. There's no random or anything. It just splats out the tile map.
Right. It just paints you combine it in a map and a store, and it just draws it. So now we need to think it generates a random map.
Mm-hmm.
Should be easy, right?
Okay. So I'm going to do that here. Yeah, we can do that here in the init state.
Okay. So let's give ourselves a map. Map. Oh, we don't know the width and the height at the moment. Because this is late.
And then this takes a store.
We just needs the count, right? Tile.
Oh, I see, because you're just doing it by index. Okay.
Okay, so I'll make that constructor on tile map.
Sure. I mean, we're done at this point then.
We have to pass it to the map.
Ideally, we should probably do this in the init state anyways too, but yeah.
Okay.
This really belongs here.
Factory.
I like the tile store style map separation. That's good. All right, my app is in class. Okay, body might complete normally. Tile map from map. Oh, that's like.
Oh, we need a width and a height.
Tiles or something.
We need a width and a height. A width and a height and a tile map. Right. You want 100 by 100? And then the tile. Oh,
okay. This is going to need.
The tile view is going to need a tile store and a tile map.
This tile view is sort of superfluous. This could just get collapsed. I don't feel like it adds anything.
Okay, want to just class it?
It's just an empty. Just put it here.
Okay, this is a tile store, tile map.
It's not even clear that this stack does anything. Like, right, the stack literally doesn't.
I'll just leave it. Okay, fine. Get rid of it.
We
use it in the game to like put overlays and stuff.
Yeah, that's fine. We can add it back. It's a couple of clicks to add it back. Okay, tile map. Can I have it? Yeah, that's fine. It's required. Okay. Get tile by index.
That's because it's the tile store. Raw image. It's mad. Oh, it's not mad for you?
Argument type image. What? Draw image. What are you supposed to take?
Oh, I think this is the difference between like an image.
Draw image. Is it like UI image versus a widget image or whatever?
Yeah, this image is actually a widget.
Yeah.
We did ourselves in here.
No, this is fine.
We could just actually load this thing from the image cache. But there's
a way.
How do we get the image cache?
UI image, like
because internally this thing is going to request it from the image cache.
Use the image descriptor API.
Yeah, we need to make an image descriptor or something. This gets a little complicated.
Flame has these.
Oh wait, we had a question. What is your advice becoming a talented programmer? Write lots of code. Just pick anything that interests you, be it waveform, collapse, and map generation games, and just try it. And then over time, you will get taste, and you'll get experience, and you'll get good at it. Just like anything.
Yep, that's my advice too. It's the 10,000 hours. Like somebody has that saying about like you'd be an expert in anything in 10,000 hours, which is 5 years.
It also helps to join a team of people who are way better than you and have them review your code. And like if people give you feedback on your code, like don't argue, just be like, just accept it. And if you're working with a talented team who's like really good, then it'll be good advice, even if it doesn't seem like good advice at the start. And you just do that for some number of years, and that's all there is to it.
Image.file. So it gives you a widget.
Yeah, I think we need to look at how this widget works. We'd like to view source it and figure out how it gets the actual image that it's going to paint. Because it goes, I remember doing all this because it goes through like 6 different layers of stuff.
UI image 2-byte data, image memory. Oh. Convert UI image to an image widget. Yeah, I want to go the other way.
You can't go the other way. The other way is not really helpful to you. There's there's a thing called an asset bundle.
Flame totally has this method.
Oh, should we just depend on Flame to do this for us?
Flame images, image loader, loads an image, and I'm almost certain this is a Dart UI image.
Okay,
Flame images load. What'd you say?
I think, did Copilot do this? No.
So yes, we could just depend on Flame. That's like a super easy way to solve this.
All right, let's do it. That seems like the expedient thing to do. There is some lower level way of doing it where we get access. So every Flutter app comes with a thing called an asset bundle, which is where image asset gets its assets from. And so somewhere, if you dig down deep enough in the framework, you'll get access to the asset bundle, which will just have a method on it. Basically, it takes in a string and gives you back various typed objects. You already need to add Flame to the project.
I just did.
Oh, but these are in our file system. They're not in the our asset bundle, right?
Yeah, but like this should work.
Well, we just read them using the file system API is what I'm getting at. We can just say like path.read bytes. Right. If we go to
well, then doesn't Dart UI? I know there's an images package that will that's like a pure image Dart decoder or image decoder. I've used that as well.
There should be one built into Flutter to do this for us. Like if we go to UI image, there'll be a way of getting it from a byte array. To obtain an image object.
Yeah, there's like a there's like an image memory. That's the widget, I think. Yeah. Okay, what am I doing? Well, you can also just copy them to the asset folder. That's also simple. But yes, you're right. We're on the file system.
I think we just read them out of the file system. We just need to figure out like, so we'll get our path here, right? So this is our path. Right, and then we're going to say file path read as byte sync. So now we need to figure out how to get the image out of the bytes. There must be something that does this, right? Flutter image from bytes. Instantiate image codec. What is that? Here we go.
Instantiate image codec.
Yeah, that's exactly what we want to do. It's in just our UI.
I see. It just gets you a codec, and then what does the codec do?
The codec will like spit out different images for every frame of your like animated GIF.
Get next frame. All right, so you just read in the U8 list, handed that the instantiate image codec.
Mm-hmm.
All right,
and then this gives us back a future codec. So we need to await here.
This needs to be async.
And that once we have
every time, or are we caching them?
Well, I think we should probably cache them all up front.
Okay. So
right.
then,
I'm just writing it out here just so we have it all. So codec that we call get next frame. Get next frame gives us a future of a frame info. This is like super low level stuff. This is why you always want to use the widgets to do this. Get next frame gets a future frame info, and the frame info has an image property. We did it, team. Okay. Yeah.
okay.
So we do want to have this sort of asynchronous like load the thing function. Right. We're going to go add all these tiles to names, and we're going to go load them all.
Yep.
Here.
We can split this out into like a builder and whatever, but this is fine. Yeah.
Yeah.
So I just put this sidecar data of tile images. We actually probably don't need the tile names, or do we?
Oh, well, might as well keep them. We probably don't need them, but
I maybe also should just smush these together into like a tile.
Like a map?
Sure, that could work too.
This is fine. We're overthinking it. Like, I feel like I'm saying that like 6 times an episode, but
you don't want me to write code.
I've become a huge. We have more chat messages. Sorry for the delay in the chat messages. We've been hacking away. Hi, thanks for joining us. Wave function collapse is the most intimidating. Yes, it's well, we haven't even gotten to that part. We're still just like loading the images off disk. It may be next episode before we actually get to some wave function.
This was image file collapse or image file load.
Okay. I feel like in my like old age, I've become way over rotated on the you ain't gonna need it like pattern. Like you ain't gonna need it. Just like you should do the simplest thing possible.
I use my first proprietary compiler to work this most. I appreciate our open source compilers so much more now. Yes.
Yeah, what happens is in open source world, things have to compete, right? And in the proprietary world, often who's ever making your compiler, there's not somebody else who's making another compiler that they're like trying to say, I have better error messages than you, right? Whereas the way that like Clang, one of the reasons it's won out over GCC is it just has beautiful error messages because that was a place they could innovate. And so they did. And then people voted with their feet. They're like, I want my compiler to tell me what I did wrong. Please spit out an error message I can understand.
Well, and like this was the existence on Windows for forever too. Like the open source compilers didn't work on Windows until they did, and then everybody's compiler got better on Windows all of a sudden.
Oh, I'm supposed to return the image. That would make sense. Okay.
Okay, the value local paint isn't used. Yes, that is true.
Oh, I was in the middle of doing that. That's fine. Okay, but now we actually need to call this. Did you call the load tile function?
Must be positive. With the tile count. Tile name's 0 or something? Oh, we never load this. We need tile. Is init state async? No, I don't think it is.
Right. So we need a future builder. Is what we're going here. So somewhere before we do all this, we're going to need a future builder.
Well, we could. I don't think we actually we can just make the thing return nothing until it finishes loading, right?
Oh, can I tell you my favorite trick for this? Is to do it in main. If you scroll up, I just made main async. Like so there's a fancy way to do it with
Yeah. Well, okay. I was just trying to call the method tile sort out. What do we call it? Load tiles.
But I'm basically putting that in main because it's a handy place to put a async code.
Yeah. I mean,
it's really not the right place to do it. Like the right place is to use a future builder.
Well, I'm about to do this right now, right?
Oh, you
are? The tile map is a product of tile store, just like this.
That's legit. Well, the way you're doing it is legit too.
Okay, so we just do that.
Yeah, the only bummer with this is here you need to say if not mounted return. It's kind of a gotcha.
Because in case we got deleted, sure, fine. And so this is then this is bang, and then this is either tile map not equal to null. Did that right, correct? What did I screw up? I put the wrong parentheses? No, yeah, I put this in the wrong nesting.
I usually don't want to put null. I usually want to put like a circular bar.
It's sad about the world. Is this supposed to be that way? What's wrong?
I think it's wrong. I think it's very wrong.
We have a parse error here.
All right, so let's trace it back. Oh, there's no fat arrow here.
Yeah, sorry. The fat arrow is JavaScript.
Oh, yeah. I think it's happy now. If tile map bang equals null.
It's kind of silly, but it should work.
Okay. Is it going to actually go? Oh, it did a thing. Okay, 100 by 100 is way too much. It probably looks like nothing on stream. So I'm going to change it to 10 by 10. And then reload it and see what it does.
Whoa. What was that weird, like, loading image or something?
There should be a circular progress indicator while it's loading the future.
Oh, really?
Why? Yeah, but why not? I mean, you circular progress indicators all day long.
I think you want more than that, but sure.
Why are they spaced out? Why aren't they stretched?
Probably just the way that we're drawing them with our. We probably our draw image.
Oh, top left.
Draw image and rect is what you want.
Yeah. You want to say draw. There's a fancier draw image that'll do what we want.
Or direct. Tile. You want. I don't know how you get the source.
Did you find the one you want? Draw image rect. That's what you want.
Yeah, I have it right there. The question is, how do I get the source image?
Oh, that's easy. That's just
tile have a rect.
Offset 0.
Oh, and then tile that size.
All that size. Yeah.
Okay, this is a little fancy, but I'll take
tile
it.
Doesn't have it. It has a width and a height, not a size. Okay, fine. All right, fine. We'll do this.
The image has it. I see. Width.
From.
Height. Oh, I see.
With
because
0,
point or whatever not.
I think because the image is like super low level, and so it doesn't know about anything. So
copy aside. It has a 2 double method. This isn't C.
I didn't write a C style cast.
Okay, I was writing JavaScript style lambda, so we're even.
Okay.
More commas. Deploy the commas. Okay.
Oh, no, great. So,
okay. So in our remaining 13 minutes, now we can get to the episode.
Now we can get the wave function collapse.
I think I should have done more in the easy bake oven, is what I'm learning from this.
I mean, I think this is a very, the audience really should tell, but to me, this is an interesting part. Like, how do you scaffold up? How do you get it going? Like, what is the dumbest thing? Here's the dumbest thing. It's the circuit is all wrong.
So, yeah, I don't think in the next 10 minutes we're going to do the wave function collapse episode. All right.
The algorithm? No. We could get started on it, or we could get rid of those ugly gaps. Let me get rid of the ugly gaps.
How are you going to do that?
I'm going to turn off anti-aliasing.
On the paint.
Mm-hmm.
Move the paint out here.
It's going to go like that. If you scroll up, you can see what I actually did. I set anti-alias to false.
Yeah. There you go.
The ugly gaps are gone. Sanity has been restored.
Oh,
we're willing to try. We're willing to try. we won't. You have to tune in next week. This is come back next week for the exciting conclusion.
I was thinking about
why don't we go talk through the algorithm?
That was it right there. But we can look at it here. So read the input bitmap. Well, so this is the from the bitmap.
So we did that. We did step 1. We read in this XML file that gave us the patterns.
Yeah. Create an array with the dimensions of the output. Okay. So that's going to be our time.
Why don't we create that data structure? Let's create the wave data structure. So this is going to be an n by each element of the array is going to correspond.
It's another grid. We need our grid method that we use in every single episode.
We can do it. Okay, let's create the wave data structure. That sounds legit. We'll do steps 2 and 3. We'll initialize the wave to a completely unobserved state. It's going to be awesome.
Each element in this array represents a state of n by n region in the output.
So it's like a tile, right? Each element is a tile.
But I think it's important here to say,
does this branch not build, or is the license server down? I feel for you. Builds that have dependencies on the network are just wrong. Your build should have no dependency on the network.
There's this whole movement about repeatable builds and hermeticity, hermeticness.
The way you enforce that is you just unplug the network cable during the build process. I found this. This is a digression, but someone submitted a patch to some project I was working on that was changing some like the early configuration steps to be like super fancy, like Go self-compiling. Like it was really neat. And I was like, okay, that sounds neat. And so I patched it in locally, and I literally unplugged the network from my device. And then I tried to run through the getting started instructions, and it fell over and died because there was some secret thing inside the Go runtime that was like talking to the internet. And so like that was my code review comment. I was like, I love your patch, except please make it work with the network unplugged. And the person was mortified. They had no conception that this thing was talking to the network. They too believed that the build should never talk to the network, but you never really know until you unplug the network cable.
N by N region is a superposition of N by N patterns of the input.
This algorithm is written in the most highfalutin way possible.
Yeah.
I will simplify it for you. For every tile, you keep track of can it be, which of the tiles can it be? So it's a bit vector.
Yep.
Right. And then
or an array.
Or an array of bools, whatever you want. And then when you place a tile, you then cross off the adjacencies.
Yeah.
And then you have to propagate a little bit.
Yeah.
Because
we could rewrite this in half this amount. Yes. Yep. And it just needs to be a wave. Yeah. Okay.
But they fell in love with the idea of quantum mechanics, right? It's clear that was their inspiration.
I see.
And so then that's how they thought about the problem. And they captured our attention by using the fancy terms. So it's a little bit. Anyway, I think we can make this wave data structure in the next 8 minutes. Does that sound possible?
Sure.
Okay, let's try.
Where is it?
Stub the network capability. Yeah. Also, in my old age, I like really concrete things like unplugging things. Then I know that it's not talking on the network.
Okay, doing it.
But in practice,
class wave.
Class wave.
And then this need a class. Why did it delete it?
It deleted class
we'll
wave.
Try again. Copilot, please.
Copilot was like, you cannot have waves. We refuse.
It's some interaction between Copilot and LiveShare. They do not like each other. Now we want class possibilities. Right? And this is like
possibilities are endless. Okay.
Again, grid. We need a grid. Totally resurrecting grid for this.
Okay, not in the next 8 minutes.
And then possibilities is just a. In other languages, you can have like a link here. I don't think you can do that in Dart. Or like a compile time concept. I guess you could just.
The possibility is that we should give it like a number of. We should give it a tile store, right?
You just want this. This needs to be like. Does Dart have a bit vector? Because you could just make it like 32 or whatever.
Well, I was thinking of making it a little bit fancier because you could, like, just tell it, okay, I placed your neighbor like this. Like, it could understand all of the symmetries or.
Okay, or we just write the. So, anyways, we want like. Oh my God, stop. Possibilities. In count. Right, and then I don't know what. Spool storage. This is just the dumbest possible. Storage is equal to build count. Your wave.
Apparently, there's a new vulnerability targeting offline systems that uses an unmodified SATA cable as an antenna. Whoa. That's cool. I mean,
I thought you were going to go to the whole compiler thing. We were going to talk about fail open or fail closed. That's where I got to in the first half of that sentence.
I'll see if I can sneak that into the build system. Yeah. So I was also worked on a project where there was a red team that was trying to like hack something into the build system. And I just like happened to be looking at the commits as they were flying by. And I saw this like crazy code fly by and I was like, who reviewed this? And it was the red team. And I like clicked the revert button right away. So if you put in crazy code that's like talking to the SATA system in the build, somebody's going to see it and be like, what is this?
make a lot of sense to me why we still have proprietary compilers in this day and age.
I mean, we don't really. I mean, LLVM is really conquering the whole world of compilers, as far as I can tell.
Because like at most, you should have like a proprietary LLVM backend.
They definitely have those. Like for, like I'm sure Apple's M whatever chip has a. Oh, maybe it's open source. I don't really know, but I wouldn't be surprised if it was.
But like some of the earlier problems of proprietary compilers is that like they have weird flags and they have to be held correctly. The whole connect to the network is a pain, but of course they have physical keys too these days. Plug into your big built machines. I think we're
Boolean. Okay, so and we want rule out, right? I mean, we probably should stop pretty soon, but like.
I mean, we're very close here, but yes, you're right.
Rule out. Boom. That was right.
Mm-hmm. And then you need to check the neighbor rules. This also needs to have outstore, right?
Yeah, we're getting ahead of ourselves. We should actually write that, but
then this is like.
Oh, they didn't. Oh, the red team did not have code review and merge privileges. It was part of their thing. They had fished somebody's credentials, and they had used that to push their code. So they did that. I don't know, fair and square. I would say. I don't know. If you're familiar with my open source contributions, you can go find this revert.
Oh, yeah, this isn't actually.
There's the verified C compiler, and there's compilers for proprietary languages. What is the verified C compiler?
I think we should.
Concert.
We should call it.
Okay, but we made the wave data structure. We initialized it. So step 3. It says do step 4. You know, it's like just start drawing the owl, then draw the rest of the owl. Like, what's the problem?
Oh, I don't think we're actually that far. I
we don't. We do have to implement the actual like idea. We've got all the scaffolding in place now. And we're rolling.
I think there's also a generalization about odd-shaped tiles. Maybe not odd-shaped tiles, but more than 1x1 tiles, which could add some complexity. If we did 3D, that could add some complexity. I think odd-shaped tiles are a thing that we could also try. Like if you watch the videos from the Townscaper guy, he talks about using this because he has hexagon-shaped tiles.
Mm.
And this algorithm does not require.
This is something we should do in a future episode. Like whenever we've been doing these game grid things, we've always used a square grid, and I think like a hexagon grid is way cool.
Yeah.
You get into some like gnarly math about like, okay, where are actually things and how do you paint them and stuff. But I think that would be fun.
But that should be totally possible because some of these algorithms, like the A-star even, right? The A-star doesn't care what your neighbors look like as long as you can explain it into the like
enumerate the adjacencies or whatever. Yeah, and then like for example, in the previous episode, we had these the dots traveling on these funny diagonals and stuff. Like it'll look way more natural in a hex grid.
Mm-hmm. Yeah. Yeah. Well, here we are under time for once. Any news from Pizza Land? You make pizza this week?
I made pizza with my parents this week.
Oh wow!
So we made a much more pizza than we normally make, and it was delicious.
We haven't made pizza in forever, but I am going to start the sourdough tonight, as I do every Thursday night. Because gotta have it ready Saturday morning. It's part of the routine.
So. Or there will be complaints. The complaint box will be full.
Yeah. Anyways, it was wonderful to see you. Great to see all of you at home. And
yeah, thanks everyone who came in the chat. And we'll see you next week.
See you next week.